Section 3.5, Linear Inequalities and Their Graphs. Definition. A linear inequality in two variables is an inequality that can be written in the form ax plus by is less than c, where a, b, and c are real numbers and a and b are not both 0. The inequality symbol can be less than or equal to, or greater than or equal to. A solution to an inequality in two variables is an ordered pair of numbers that, when substituted for the variables, make the inequality a true statement. Determine if the following points are solutions of the inequality 3x plus 5y is greater than or equal to 15. So, in order to determine if they're a solution, we will substitute, in our first example, negative 2 for x. So we'll have 3 times negative 2 plus 5 times y is 1. And the question is that greater than or equal to 15? So negative 6 plus 5, is that greater than or equal to 15? Negative 1, is that greater than or equal to 15? No. It is not greater than or equal to 15, and it is not a solution. Now let's substitute 6, 0 into the inequality. 3 times 6 plus 5 times 0 is greater than or equal to 15. 18 plus 0, is that greater than or equal to 15? Yes. It is a solution to the inequality. 2, 5. 3 times 2 plus 5 times 5. Is that greater than or equal to 15? 6 plus 25. Is that greater than or equal to 15? Yes, it is. 0, 0. 3 times 0 plus 5 times 0. Is that greater than or equal to 15? No, it is not. It is not a solution to the inequality. Let's graph 3x plus 5y is greater than or equal to 15. The first thing we need to do is we need to figure out where the boundary is. 3x plus 5y is greater than or equal to 15. So where it equals to 15 will be the boundary. So where does 3x plus 5y equal 15? We know how to graph a line like this. It's in general form, so I prefer to graph lines in general form by the intercept method. If x is 0, you get 5y equals 15. So y is 3. If y is 0, you get 3x equals 15. So x is 5. So it goes through the points 0, 3 and 5, 0. So this is the boundary. This is where 3x plus 5y actually equals 15. Let's look at our solutions up here. What did we find out? We found out that negative 2, 1 is not a solution, but 6, 0 is a solution. Where's 6, 0? It is right here. So we know that that is a solution. 2, 5 is a solution. Where are the ones that aren't solutions? Negative 2, 1 is not a solution. 0, 0 is not a solution. Those won't work. So, what do you think? Where are the solutions? We have 2 points that are solutions above the line, and we have 2 points that are not solutions below the line. Let's check one more point above the line. How about the point 5, 5? If you substitute 5, 5 into the inequality, you get 3 times 5 plus 5 times 5. And is that greater than or equal to 15? Yes, it is. So that's another solution. It seems like all the points above this line represent solutions to the inequality. We know that the boundary, the line itself, is part of the solution because it can be equal to 15. But it must also be greater than 15, and that seems to only be happening where points are above the line. So when we graph linear inequalities in two variables, we graph the corresponding linear equation, that's the boundary. For an inequality with symbols greater than and equal to or less than or equal to, we draw a solid line. For an inequality with symbols greater than or less than, we draw a broken line. A broken line is just a dashed line. This line is the boundary between the part of the plane, the half plane that is the answer, and the half plane that is not the answer. If the line is broken, that means the boundary is not part of the answer. If the line is solid, it means that the boundary line is part of the answer. So how do we decide which half plane is the answer? We use a test point. We pick a point, any point above or below the line. We chose 3 different points here to test, and we found out that all 3 points above the line worked. You can check just one point, one single test point. If that one single test point, either above or below the boundary, makes the inequality a true statement, then you know that all points on that side of the boundary are part of the solution, and all points on the other side are not part of the solution. So let's graph y is less than x plus 2. So the first thing I do is I underline the problem with a broken line. If I know that that needs a broken line, that reminds me that when I graph this line, I have to be careful and make sure it's broken or dashed. So my line that I'm going to graph is y equals x plus 2. We know how to graph a line like that. We know that we begin with the y-intercept, 0, 2, and then we use the slope. What's the slope of this line? 1. That's positive, so it's going to be going uphill, and we think of it as 1 over 1. So we start with 0, 2. Then we use our slope. We go up 1 over 1, up 1 over 1, up 1 over 1. That's our line, and we're going to draw it with a dashed or broken line to show that it is not part of the solution. Now we need to choose a test point. Is the solution going to be above or below this line? I love to choose a test point of 0, 0. It's my favorite test point because it's so easy. So I substitute those values into the inequality and I see if it's true. Is 0 less than 2? Yes, it is. That's true. So our solution will be all points on the same side of our boundary line as our test point of 0, 0. And that is the solution. That's the set of all points that make this inequality, y is less than x plus 2, true. Y is greater than or equal to 4x. I underline my problem with a solid line to remind myself that my boundary line is going to be solid. It will be part of the solution. So y equals to 4x is our boundary. That is a straight line. It has a y-intercept. There's no number out here. So the y-intercept is 0, 0. The slope is 4. We can think of it as 4 over 1. It's positive, so we're going to go uphill. 0, 0, up 4 over 1. We can go up 4 over 1 again. We can go down 4, left 1, down 4, left 1. Just as long as we're showing that our line is going uphill. I can't use my favorite test point. 0, 0 is on the line. So it can't be a test point. A test point has to be very obviously off to one side of the line. So I'm going to pick a point off to the right. How about the point 3, 0? That'll be easy. So putting it in the original equation, we have 0 is greater than or equal to 4 times 3. Is that true? No, that's false. And since the point 3, 0 is not part of the solution, then we know that all points to the right of this line are not part of the solution. All points to the left, then, must be part of the solution. The boundary line and all points to the left represent the solution. This next problem, we have x is greater than or equal to 1. Our boundary will not be part of the solution, so we draw it with a broken line. Where is x equal to negative 1? That's where our boundary is. X equals negative 1 is a vertical line that crosses the x-axis at negative 1. Where is x greater than negative 1, larger than negative 1? I don't even need a test point for this because I know that x is greater than negative 1 to the right of this line. So I shade in to the right of the line. The solution consists of all points to the right of the line x equals negative 1, and the boundary line is not included in the solution. Graph y is less than or equal to negative 3. It's solid. Where is y equal to 3? Horizontal line, we draw it solid. Where is y less than 3? Now think about the y-axis. If you go up, you go positive 1, positive 2, positive 3, positive 4, positive 5. Where are the values of y that are less than 3? Below that line. So this is our solution. Let's graph negative 2x plus 4y is less than negative 8. This is going to be a broken line. The boundary line will not be part of the solution. How do we graph negative 2x plus 4y equal to 8, our boundary? It's in general form, so I like to use the intercepts. Let's let x be 0. If x is 0, we get 4y equals 8. Y is 2. Let y be 0. If y is 0, we get negative 2x equals 8. Divide both sides by a negative 2, and you get negative 4. So we have 0, 2, and we have negative 4, 0. Our boundary line is not part of the solution. I need a test point. The point 0, 0 is obviously not on the line, so it can be our test point, and it's so easy to use. You get 0 plus 0 Is 0 plus 0 less than negative 8? Is 0 less than negative 8? No, it's not. So 0, 0 is not part of the solution. So our solution will be all points above the line. If the test point works, you shade that side. If it doesn't work, you shade the other side. You have a maximum of $1,200 to purchase a stock. You can purchase X shares of stock A, selling for $12 apiece, and Y shares of stock B, selling for $15 apiece. Express this information as an inequality. So you're buying stock. Stock A costs $12 for each one, and we're buying X shares of it. Stock B, or stock Y, or we're buying Y shares of stock B, and they're selling for $15 a piece. You have a maximum amount to spend. That's $1,200. Can you spend exactly $1,200? Yes. Do you have to spend all of it? No. You can spend less than or equal to $1,200. So let's graph this inequality. I like this general form, so I would like to make a t-chart for the intercepts. If we let x be 0, we have 15y equals 1,200. How many shares of stock B can we buy then? If we divide both sides by 15, we get 80. You can buy 80 shares of stock. So we have 15y equals 1,200, and we get 80. If we let y be 0, we'll end up with 12x equals 1,200. Divide both sides by 12, we get x equals 100. So those are our two intercepts. This inequality is less than or equal to, so it's a solid boundary. The boundary is included. We only want to stay in quadrant 1. Why is that? Can we purchase negative shares of stock? No, we're not going to do that. We want 0, 80 is our y-intercept, and 100, 0 is our x-intercept. Staying in quadrant 1, that's our line. And the question is the solution above or below the line? 0, 0 can be our test point. So if we substitute x equals 0 and y equals 0, we will get 0 is less than or equal to 1,200. So it works. Staying in quadrant 1, this is our solution. It makes sense too. You can spend a maximum of $1,200, so it makes sense that you would have to stay under a certain amount. Use the graph to determine if you can purchase 30 shares of stock A and 40 shares of stock B. Now remember, we purchase X shares of stock A and Y shares of stock B. So we want to know if the point 30, 40 is in our solution. Yes, you can do that. You can. Use the graph to determine if you can purchase 50 shares of each. So this time we want to purchase 50 shares of each. We're looking to see if the point 50, 50 is in our solution space. 50, 50. It's really hard to tell from the graph. I think 50, 50 is not in our solution space. So I'm going to say no, you cannot. I'm a little nervous about that answer though. So, gosh, I wish there was some other way that we could figure out if that really is not a part of the answer. We have our equation. It's 12x plus 15y is less than or equal to 1200. Can we substitute 50, 50 into our equation and find out, is that less than or equal to 1200? According to the graph, we don't think it is. We think it's greater than 1200. But it won't hurt us to try. We need 12 times 50 plus 15 times 50. And sure enough, we get 1350. That is not less than or equal to 1200. So we were right. You cannot purchase 50 shares of each. That's $13.50, and the maximum that we can spend is $1,200. A local flower shop sells a small Christmas arrangement for $35 each and a large Christmas arrangement for $60 each. The owner of the shop wants revenues from the sales of Christmas arrangements to be at least $4,200. We have to express this information in an inequality. Let's take 35 times x and 60 times y. That has to be at least greater than or equal to 4,200. What does x represent? The number of small arrangements. What does y represent? The number of large arrangements. Let's graph it. It's in general form. It's greater than or equal to, so we're going to have a solid boundary. Since it's in general form, I really like to use the intercept method. If x is 0, then we have 60y equals 4,200. That means y is 70. If y is 0, we have 35x equals 4,200. Divide both sides by 35. 4,200 divided by 35, 120. So we have 0, 70, 120, 0. Solid boundary, staying in the first quadrant. You can't sell negative flower arrangements. We need to decide whether or not we're going to stay above or below our boundary line. Remember, we want at least, at the very least, $4,200. So let's use our test point. 0, 0 is up for grabs. Let's do it. 0, 0. Substitute it into the inequality. You get 0 plus 0. Is that greater than or equal to 4,200? No. If you sell 0, you haven't made any money at all. So you need to be above this boundary line. Our solution is on the boundary line. You'll make exactly 4,200. Above the boundary line, you'll make more. So use the graph to determine if selling 80 small arrangements, now wait a minute, which one's small? That's x. And 50 large arrangements, we chose to make the large ones y. Is the point 80, 50 in our solution area? Where is the point 80, 50? 80, 50. It looks to me to be about right here. Yes, it is in our solution area. It will make sure, if we sell 80 and 50, that'll make sure that we make at more than 4,200. Use the graph to determine if 55 small arrangements, remember, that's x, 40 large arrangements, that's why, if that will generate the desired income. Where is the point? 55, 40. I think it's just beneath the boundary, but I'm not sure. If you're unsure looking at the graph, you can always use the inequality to check the answer. 35 times x, and x is 55, plus 60 times y, and y is 40. Is that greater than or equal to 4,200? 35 times 55 plus 60 times 40. Oh, that's actually 4,325. That is greater than or equal to 4,200. So I don't think I put that line in the right place. Let's erase that point, because that point doesn't go beneath the boundary. That point is just slightly above the boundary. If you have trouble telling from the graph, you can always use the inequality. Yes, it will. If I had just looked at the graph, I might have thought the answer was no. That's all for this tape.